DNA barcoding, one of the newest technologies introduced to communities. It was first introduced to us by Paul Hebert in 2003. Hebert is a biologist and professor at the University of Guelph in Ontario and founded the Barcode of Life project. Today we are joined by biologist Paul Hebert. Mr. Hebert, what's DNA barcoding? How does it work?
DNA barcoding assists in identifying species and to discover diversity in taxonomy. Scientists sample many species which have been discovered previously with similar genus to evaluate the species. The analysis is based on the interspecific variations between the two compared species. DNA sequences, which are usually short, are used to describe the species. They are usually quite helpful in allocating identification to the new species being discovered. mtDNA are also used to assist in these discoveries. Furthermore, species physical structures are used to assign the species to a specific geographical area. DNA barcoding is an accurate and quick way to identify species with a short DNA sequence rather than the entire genome in eukaryotes.
What inspired you to create this technology?
Mostly by how supermarket scanners function, how little black lines can look so similar to others but differentiate between objects. Before barcoding, biologists relied on morphological traits to identify species. However, this was not reliable, as some could be immature or damaged, causing an error in identification. Barcoding allows scientists such as taxonomists to simply acquire a barcode with a small specimen of a tissue.
What are some key principles involved in DNA barcoding?
Barcoding is split up into two different sections. The first is a diagnostic of a species at a molecular level to describe taxa, and the other is to use DNA to discover new species. One important material to use in the procedure of DNA barcoding is COI. Every species has different COI sequence, and so this assists us in distinguishing species rather than relying on a molecular diagnostic. COI is very useful in identifying between domains and kingdoms, specifically in Animalia, Plantae, fungi. COI is a gene section in the mitochondria which helps us in the procedure of DNA barcoding. Welcome to CBC News.
Just when you thought it was over, it's not. Paul Hebert has brought upon the idea of a new technology called DNA barcoding.
Its applications to taxonomy are important, however, it may become controversial in the science world.
Let's look at the basics. DNA barcoding in the past few years has helped to understand and monitor changes in the diversity of our environment. With its quick and efficient identification of species, organism identification becomes simple and easy for anyone in the world to do. But what concerns us is you. What will it do for the public, Jasvinder?
There's plenty, but mainly controlling agriculture pests, identifying diseases, sustaining natural resources, protecting endangered species, monitoring water quality, checking the authenticity of natural health products, and identifying medical plants.
That's amazing! These are the exact things that might become available handheld. The barcode is used in our daily lives, being used for inventorying, classifying, and becoming a part of our lives. Today, there are many assumptions that the public does not have any intimate relationships with nature or animals. Many are ignorant towards other living things, completely disregarding their importance.
Also, to enlarge genes in order to allocate unidentified species and to improve the discovery of new species. There are many reasons as to why DNA barcoding is being pursued by scientists. One of them is the preservation of species due to the damage done to the habitats. Because of the alarming climate change, many have gone extinct without being identified. DNA barcoding is accurate, accessible, and fast at the same time.
Bioliteracy will transform a world that is not connected to nature at all to a world that will have a close and strong epistemic to our natural world.
But there are some things that you should watch out for as DNA barcoding becomes a daily part of our lives. When a hybridization arises between species, barcoding becomes variant among the groups depending on the evolutionary history. This will make it much more difficult to specify certain organisms on certain species.
When looking at our economy, we can expect some downfalls, considering that the technology takes up money in terms of funding. Extended support has led to approximately $100 million in grants that have been used for a research program revolved around DNA barcoding, and to establish the basis of this information. BOLD, the Barcode of Life data system, has global efforts bringing together over 26 countries to strengthen the research socially, culturally, and economically. This brings inclusiveness and strengthened political relationships.
But to end up on a good note, of course, there will be more jobs in the field, broadening the economy. So all you undergrads out there will be jobs out there waiting for you.
Created using Powtoon.